prime factorization. Prime factorization occurs when we divide the numbers into all prime numbers. One method for finding these numbers is to use a factor tree. So let's go ahead and look at what a factor tree is in the first example. So what is the prime factorization of 480? So what we're going to do is we're going to write 480 at the top, and then we're going to have these branches that come off, just the two. So we notice that 480 is even, and usually this is what I look at. Is it even or is it odd? And if it's even, I go with the easy, simple, let's just go ahead and divide it by 2. So 2 can go into 480 240 times, right? If we just cut it in half. And it's really just looking at, say, the 48, which is like 2 days. Say go ahead and divide 2 days into 1 day, it's just 24. But you can't forget that 0 at the end. So that's one way I think about it in my head. Then we look at 240. Well, that can be broken down into 2, again, right, because this is even. And then, right, if we were looking at just the 24, like say, so it's 24 hours, you break it into half, well, that would be 12. But then we have to add the 0, right, because 120 plus 120 is equal to 240. So we did that. Then we're going to go ahead and break this down even further. Right, we're just breaking it down into prime numbers. So once again, we can divide by 2, and then we have 60. Now 60 can be broken down into also 2, and then 30. 30 is still even, right? So we're going to keep breaking it down in 2s. So which is 2, and then 15. Notice that now, right, we have 15. Well, that can be broken down into, right, so no longer 2, but this can be a 5, right? We can break this down because it ends in a 5. 15 divided by 5 is then 3. So notice we're done. We don't have any more numbers we can break it down into because we all have prime numbers at the end. So what we're going to do is go ahead and circle all the prime numbers. So notice we have a lot of 2's. We actually have 5 2's, so we're actually going to rewrite this. So that's 2 times 2 times 2 times 2 times 2 times 3 times 5. I just switched the order so it's, increasing order. Now, we're actually going to rewrite this, right? Since we have 5 copies of 2, right, we know that if we do exponents, that says we have 5 copies of the 2. So we can just go 2 to the 5th power times 3 times 5. And then that would be the prime factorization of 480. Now let's go ahead and look at another example. So example 2. So a second method is using a divisibility ladder. So let's go ahead and look at that. So we have 1,890. So we're going to take the prime factorization of it. And the second example. So we're going to kind of start a little bit lower. And we're going to start with this number here. And we're going to draw, right, like we're going to go ahead and divide. But we're going to pick the number out here, right? Usually they tell us what to divide it by. But we're going to look at this number, and we notice that it's even, so I'm going to divide it by 2 first. So we're going to go 2. So 2 can go into 1,890 how many times? Right? Well, 2 can go not into 1, but 18, 9. Then we just move on. So we just kind of keep it in there. We don't write anything below, because you'll see why. Now 2 can go into 9 4 times. But 2 times 4 is 8. So 9 minus 8 is, there's going to be a leftover 1. So we're just going to go ahead and put that 1 right there. Right, because we usually bring down the 0 with the 1. So that's now 10. Now 2 can go into 10 5 times. Now we're going to go ahead and keep dividing. So notice how we're going to create this ladder here. Now it's not even anymore, but it ends in a 5. So let's go ahead and divide by 5. So 5 can go into 9 one time, but then we're going to have a 4 left over because 9 minus 5 is 4. Now we have 44. So 5 can go into 44 8 times because 5 times 8 is 40. We go ahead and subtract and we have still 4 left over. Now feel free if you want, if you like this method, but just go ahead and do it over here if you have to have it where you have all the numbers underneath, right? And go 5 can go into 9 one time. We go ahead and subtract, we get 4. We bring down the 4. So that's why we got the 44 there. Now 5 can go into 44 8 times. We go ahead and subtract, we get a 4. Now we bring down that 5. Now 5 can go into 45 9 times. We go ahead and subtract, we get 0. So once again right here, it's a 9. Now remembering our divisibility tricks, 1 plus 8 plus 9 is 18, which can be divided by 3. So let's go ahead and put a 3 there. Now 3 can't go into 1, but it can go into 18 6 times, because 3 times 6 is 18. We have nothing to carry over. Now 3 can go into 9 3 times. Notice we have 63. Let's go ahead and divide by 3 again. So 3 can go into 6 2 times. And then 3 can go into 3 1 time. Right, and there's nothing to carry over. So that's why it was just very simple on that one. Now 21. Well, 21 can be divided by 3 and 7. And then we're done because we have all our prime numbers. We can't break this down anymore. So let's go ahead and rewrite this. So we have 2. Let's go with the 3s. We have how many 3s? We have 3 3s. 1 5 and 1 7. So let's go ahead and rewrite this with the exponents. So we have 2 times 3. We only have 1 2. So we have 3 3s. So we're going to say we have 3 as our base number, and we're going to have 3 copies of 3. Then we have 5 times 7. And that would be the prime factorization of 1890.